This is a video presentation of Chapter 7, Section 5, Coordinate Geometry. So yesterday, you remember what we did is we went back and we took a little detour and we went and looked at the coordinate plane, and where we had been before that was looking at two-dimensional geometry. So now those two things are going to come together, and that's what this section is all about, coordinate geometry. So we have one new definition here, the midpoint. The midpoint is the point that divides a segment into two congruent segments. Now, if you recall, yesterday one of the things we did is we found the distance between two endpoints on a line segment when laid on top of the coordinate grid. That's kind of the idea here, except they're really going to be doing this not just with horizontal and vertical lines, but also lines that run what would appear to be diagonally across the coordinate grid. So with that in mind, let's go ahead and start taking a look at the examples here in this section. In question number 1, they're asking me to graph the polygons with the given vertices, and then we're supposed to give the most specific name for each polygon. And they tell us they want A to be 0, -2, and B to be 3, 3, and C to be 3, -2. So that is nothing different than what we saw yesterday. You're going to plot the 3 points. The difference is, from yesterday, you're then going to connect those points, in this case 3 points, to make a figure. So, taking a look at what we're doing here, we're supposed to plot the point called A at 0, -2. So remember, that means its x-axis number is 0, so that means I'm not going right or left, and the -2 then means I'm going to go down 2. So that's this point you see right there. The B point, 3, 3, should be very hard to screw up since the numbers are the same. 3, 3 means from the origin I'm going to go right 3 and up 3 and put a point. And the C point is 3, -2, so from the origin I go right 3. Remember, the first number is an x-axis number, this is the x-axis. And then the second number being -2 means I'm going to go down 2. And then I just connect my points, and obviously the shape I have is a triangle. Now that's not just any triangle though, which is what they're talking about there in step 1. Obviously there, that angle that's shown on the bottom right, well, it's kind of even marked by the grid lines. We have a right angle there. So that is very obviously a right triangle. Now what they do in the second step is they take it a step further and they then classify the triangle by its side lengths. Now they're using in part what we learned yesterday here, in that they can find the length of the side that runs, or the sides rather, that run parallel to the grid lines using that same formula that we used yesterday. So remember here with A is at 0, -2, and C here is at 3, -2. We subtract the numbers that are different. Ignore the set are the same. Well, the y coordinates are the same both at -2. That would be pretty boring. But we're going to subtract the x ones, the ones that are different. 3 minus 0 means that has a side length rather of 3, which is what you see right here. And again, that's what we saw yesterday. For BC, the side that runs north-south, well, this is up here is at 3, 3. And again, we ignore the set that is the same. Well, the x coordinates are the same here, so we want to work with the y coordinates. And again, we subtract those to find the distance. 3 minus -2, or -2 minus 3, and then take the absolute value. It doesn't really matter which you do, is 5. Now, the one that is going to require something new for us here is the side marked AB. We're going to have to use the distance formula here.